Good morning, 11th graders at Amjad High School. This is the math department. Today our chapter is about the derivatives of trigonometric functions. First, let's remember the following rules of derivatives that you've studied at the beginning of this year. Assuming what follows, that u and v are two functions of x and that a is a constant. First, if the function is a constant, if f of x is in the form of f of x equals a, where a is a constant, then the derivative is 0. If the function is in the form x to the n, then for sure you drop this n and you subtract 1 from the power, it's n x to the n minus 1. If it's a constant times x to the n, then you multiply this constant by the derivative of x to the n. If the function is in the form ax, its derivative is a. Notice here that ax is nothing but the equation of a line, and consequently the derivative is the slope. Some of the standard important functions, like 1 over x, its derivative, you should know it directly. It's minus 1 over x squared. Radical x is another standard function. It's 1 over 2 radical x. If you have a function which is in the form of a sum, then the derivative of u plus v is u prime plus v prime. In other words, the derivative of the sum is the sum of the derivative, similarly for the subtraction, whereas in the case of the product, it's the product rule u prime v plus v prime u. In the case of the quotient, it's u prime v minus v prime u over v squared. If you have a constant times u, then the derivative will be the constant times the derivative of u. If the function now is in the form of radical u, this is similar to radical x, but this is a composite function. If radical x is 1 over 2 radical x, then you should expect that radical u is similar to that 1 over 2 radical u, but the only difference here is that you need to multiply by u prime. Similarly, u to the n is nothing but nu to the n minus 1, but times u prime. You know these rules since first semester. Some applications, find the derivative of the following functions. If f of x is in the form 1 over 5x to the 3 plus 4 over 3x squared minus 8x plus 3 over x minus 7. The derivative, this is a sum. So you derive each term alone, and each term has its form clearly here to the right. The first one is in the form ax to the n. So its derivative, you drop this 3 and you subtract 1 from the power. This is 4 over 3x squared. You drop this 2, it will be 8 over 3x. 8x is 8. 3 over x is nothing but 3 times 1 over x, so it remains as 3 times the derivative of 1 over x, which is minus 1 over x squared, and clearly the derivative of 7 alone as a constant is 0. You can simplify a bit. Next, f of x is ax plus b over bx plus a. What is most important when you're finding the derivative is to match the function with the appropriate form. So this is u over v. This should be read as u over v, where u is ax plus b, and where v is bx plus u. Consequently, u prime is a, v prime is b. So now you're applying the rule and nothing but plugging in the corresponding quantities. Simplifying a bit in the numerator, you will get a simplified final answer as a squared minus b squared over bx plus a all squared. Next function, 3x squared minus x plus 2 power 3. Before deriving, you should make sure that you are reading the function in the appropriate or convenient form. This is in the form u to the n, and consequently the rule is nu to the n minus 1 times u prime. So you drop this 3, you subtract 1 from the power, and u prime is nothing but 6x minus 1. You can simplify by introducing this 3 inside the brackets. It will be 18x minus 3 into u squared. Next function is 2 radical x over 3x squared plus 7. Again, this is in the form u over v, where u is 2 radical x, and you should know its derivative, where v is 3x squared plus 7, and clearly its derivative is 6x. Applying the rule of u prime v minus v prime u over v squared. By the way, you can keep your answer like this for now. We're not learning now how to simplify. We're learning how to apply the appropriate rule. But in all cases, in this presentation, some simplification is given. if the function is in the form radical 4x squared minus 2x minus 7. So you read this function as radical u, and consequently the derivative will be u prime over 2 radical u, simplifying to get the final simplified answer. Now, what about functions with trigonometric expressions like sine x or cosine x or whatever? So in part 1, assume that the function is sine x, cosine x, tangent x, or cotangent x. You should know the derivative of these. You haven't studied this in semester 1, but now you're responsible to know the derivative of these. For sure, if we want to prove or to find by proving the derivative of sine x, we need to start from the basic definition of derivative, which is a limit definition. It's the limit of f of x minus f of x 0 over x minus x 0. For now, you're not responsible to prove it. You're responsible to know the rule now by heart. So the derivative of sine x is cosine x. It's nice that you try it by yourself if you like to prove it by starting from the limit definition, especially for those students who are willing to go to GS. They should think of some proofs and how they work. The derivative of cosine x is minus sine x. The derivative of tangent x is 1 plus tangent squared x, or 1 over cosine squared x. The derivative of cotangent x is minus 1 over sine squared x, or minus 1 minus cotangent squared x. You should know these by heart. Applications. Find the derivative of the following functions. F of x equal cosine x minus 2 sine x. This function is in the form of a difference or sum. So you have to derive each part alone. The derivative of cosine x, as mentioned in the previous page, is nothing but minus sine x. And the derivative of sine x is nothing but cosine x. Again, you should know these four formulas or rules by heart. Plugging in the values, this is the answer. What if the function now is in the form t cosine t? The variable here is t and not x. This is a product form, and consequently it's u prime v plus v prime u, where u is t and consequently u prime is 1, v is cosine t and consequently v prime is minus sine t. Plugging in u prime v plus v prime u. Let's move to the next question. Tangent x plus x over sine x plus 3. Again, this is in general in the form of a sum, so you need to derive each term alone. The first term is tangent x. It has its own rule, 1 over cosine squared x. The second term is a quotient. It's u over v. So you need to apply u prime v minus v prime u over v squared. The third term is a constant, and its derivative is 0. You can keep your answer like this, or you can simplify like this. You don't need to worry here how we are simplifying. It's just simplifying expressions and writing this expression as one fraction. Again, sine squared x plus radical tangent x plus cosine to the power 4x. As I mentioned before, the most important or the most critical issue for students to know how to derive is to know how to match each term with the specific form. Sine squared x matches which one of the rules? Actually, sine squared x is nothing but sine x all squared, which means that it's in the form of u power 2. So that's 2u to the 1 times u prime. What about radical tangent x? This is in the form radical u. So the derivative will be u prime over 2 radical u, and u prime here is 1 over cosine squared x, because we mentioned that the derivative of tangent x is 1 over cosine squared x. What about cosine to the power 4x? Again, it's in the form of u to the 4. So the derivative will be 4u power 3 times u prime, which is minus sine x. So cosine to the 4x as a form, it's matched with u to the n. Part 2. Assume that u is a function of x. We have learned now what the derivative of sine x is. But what if the function is in the form sine of 3x or sine of x squared or cosine of x plus 1. So you may find some functions which are matching these forms, like sine of an expression, cosine of an expression, tangent of an expression. Since the derivative of sine x is cosine x, you should expect that the derivative of sine u is very similar. The derivative of sine u is simply cosine u, but the only difference is that you need to multiply by u prime. Since the derivative of cosine x is minus sine x, then the derivative of cosine u will be minus sine u, but you multiply by u prime. The derivative of tangent x, we just explained this, it's 1 plus tangent squared x. So the derivative of tangent u is 1 plus tangent squared u, but multiplied by u prime, or u prime over cosine squared u. It's the same. Application 1. Find the derivative of the following functions. F of x sine of 3x plus 2 plus cosine minus x plus 3. This function is a sum of two terms. The first term is in the form sine u. The second term is in the form of cosine u. So the derivative of sine u is u prime cosine u. Now the derivative of cosine u is minus sine u, but you need to multiply by u prime, which is minus 1 here. That's why the final answer will be plus sine of u. Next, f of x equals sine ax plus b plus cosine ax plus b. This is very similar to the previous one, but u and v are different. So again, the derivative of sine u is u prime, which is a, times cosine u, which is ax plus b. Now, cosine u, the derivative is minus u prime sine u, but u prime is nothing but a, and consequently this is minus a times sine ax plus b. So the derivative of cosine u is minus sine u times u prime, and u prime is a here. F of t is cosine of t squared plus 1 minus tangent 3t squared minus 4 plus 2 sine of t cubed plus 1. This is in the form of cosine u. This is in the form tangent u. This is in the form sine u. Again, you are applying the same rule. So the derivative of cosine u is minus sine u times u prime. What's the derivative of tangent u? The derivative of tangent u is u prime over cosine squared u. So, and don't forget you have a minus here. It's kept as a minus. So tangent u is u prime, which is 16, over cosine squared u. Now this is a constant times sine u, so you will keep the constant, and u prime will be 3t squared, and sine u will be cosine u. Let's consider this function now. Cosine squared of pi over 2x minus 1. Again, what is the appropriate form? This is actually in the form cosine pi over 2x minus 1 all squared, which means it's u to the n, where u itself is in the form of cosine u. So the derivative of u to the n is n. First of all, you need to drop the exponent. You subtract 1 from the power. Then you have to multiply by the derivative of u. This is cosine u itself. So the derivative will be minus sine u times u prime, which is pi over 2. By the way, this is called a chain rule. You are deriving everything. You are deriving the exponent. You are deriving the cosine. And you are deriving the linear function inside. So the derivative will be u, or n, sorry, n times u to the n minus 1 times u prime. But u prime itself is in the form of cosine u, and the derivative of cosine u is minus sine u times u prime. Simplifying a bit, you will get this answer. What about sine of x squared plus sine squared x? You have to differentiate between the forms of these two parts. Sine x squared is read as sine u, whereas sine squared x means sine x all squared. It means it's in the form of u to the 2, that is u to the n. So concerning the first part, it's sine u. and the derivative will be u prime cosine u. What about the second part? The second part is sine x all squared, which means it's in the form u to the n. So first you need to drop the power and subtract 1, then multiply by u prime. By the way, 2 sine x cosine x can be written as sine 2x, but here we're not concerned about the form of the final answer or simplifying the answer, unless the teacher is asking you to write your answer in a specific form. But now it's okay, just you are applying the rules correctly. Application 2, find the slope of the tangent t to the curve of the function f defined as f of x equals x sine 2x at the point with abscissa pi over 6. You should think of this, and I'm sure that some of you can solve it correctly without even my explanation. First of all, to write the equation of the tangent, you need to find the slope of the tangent. And the slope of the tangent, as you know, is nothing but the value of the derivative at the x-coordinate of the point of tangency. So it's f prime at pi over 6. Now let's derive the function. What is the form of the function? It's in the form u times v. U is x, so u prime is 1. V is sine 2x, which means it is in the form sine u. And consequently, its derivative should be cosine u, u prime. So here, v is sine u, its derivative is cosine u, u prime. So plugging in the values, you will get this expression. It's sine 2x plus 2x cosine 2x. So the value of the slope at the specific point is f prime at pi over 6. So this will be sine 2 times pi over 6 plus 2 times pi over 6 times cosine 2 pi over 6. You can use your calculator to get the answer. So the tangent, the slope of the tangent is nothing but radical 3 over 2 plus pi over 6. By the way, you are just asked to find the slope of the tangent and not the equation of the tangent. So we are done. Thank you for this session.